And we'll right now continue with Mr. Kova. Mr. Kova gladly helped us out. We were missing one presentation here for health reasons, and I kind of kidnapped him on the last way, because I know he's a specialist, and he came now also traveling and helping us to understand the ways of making energy and also producing biochar. And he's now also, I think, thinking of some new projects in Latin America to use the technology. So we are extremely excited to hear from you, and thank you so much for jumping in such short notice. Thank you.
And I'm very glad to know that nobody leaves the stage without a present. I'll try to give you an idea about the economic potential of coffee cherries and other farm waste for the production of energy and activated carbon. O2HC stands for organic to hydrogen and carbon. The O2HC process is a steam cracking process. This was developed and as an idea by me and my colleagues about 12 years ago. Back then, climate change was just a word, and gas was cheap. The public discussion took place later. That's what made me and my business partners think about looking into the process again 3 years ago. During this time, we have developed the process to this current status. The costs so far have been about 3.5 million euro. The status. The lecture deals with the presentation of the OCR process and the ecological and economic possibilities for the recycling of organic waste from coffee farms. The development of the process is on a pilot scale and is to be implemented in cooperation with the GIZ, Deutsche Gesellschaft für internationale Zusammenarbeit, in model projects in Mexico and Brazil. Materials, planting, harvesting, and processing of coffee produces big lots of biomass, which is not yet utilized. The farmland has to be constantly cultivated. The soil has to be recreated and optimized. You also have on the farm big amounts of vegetable or other biogenic waste materials, scrub, green waste, and so on. The objectives of the OCS process, construction and operation of a plant for the production of hydrogen-rich synthetic gas for energy production and for the production of biochar. That's target 1. Then diversification of the business model through the use of biochar on the farm as a CO2 sink. This generates CO2 credits. The next is diversification of the business model through the producing of selling barbecue, charcoal, or black carbon for the industry. Biorefinery for the extraction of raw materials from harvest remaining for further use in green chemistry and for the production of food. Now I'll give you an idea how the process works. The raw materials goes, if it's needed, into a shredder, and then we have to dry it up to 85% dry matter. Then it goes into the reactor, and after that you can give the gas to a power plant and produce their electricity, warmth, and you have a quickly controllable base load capacity as an addition for solar and wind energy. And the biochar can be used for the reduce of CO2 in the atmosphere, can be used for substrate, soil conditioner, terra preta, and organic minerals fertilizer. This is reducing the costs on the farm Here I'll give you an idea about an example. A family-run farm produces the following amounts annually. Coffee cherries about 1,500 tons, horn shells about 720 tons a year, and shrub and other green waste 18 tons. The dry matter of horn shells and shrubs and green waste is sufficient for the process. The coffee cherries has to be dried up to more than 80%. This means that there is a total measure of approximately 500 tons a year. It therefore makes sense to generate additional biomass to increase capacities. The best cost-benefit ratio is on a plant between 1,000 up to 5,000 tons input a year. The usable amount of biomass waste in our example is approximately 1,200 tons a year. This amount can be treated with the smallest O2HC plant. However, the invest for this size of plant is relatively high in relation to the return of the invest. Therefore, it can be an advantage to recommend additional biomass. For example, feedstock, manure, wood chips, corn stalks, or straw, and so on. And these are some pictures of corn stalks, wood chips, and the blue hydrogen flame. The black background is required to make the flame visible. If you don't have a black background, you don't see any flame. The biochar is a highly quality soil conditioner with the following properties. Retention aids water retention during times of constantly rain, moisture release during the dryness periods, fertilizer depot saving of mineral fertilizers, aggregate for cultivated soil, terra preta, and CO2 sink when you storage it on the farmland. And this means you can get CO2 credits, which is a significant economic factor. This is a picture about terra preta, and these are pictures of the CO2 equivalent. 1 cubic meter of wood is 1 ton biochar, and this is approximately 3 tons of 3O2 equivalent. The next page shows the basic prices of TO2 carbons and for removal credits. I don't have it in English, I only have it in German. But a concrete calculation depends on the projects at all. This is a figure of a flow chart of the energy supply network site, which has to be installed on the farm as an energy center. On the one side, you see the gas. The gas grid goes into the power plant or directly into a grid. The electricity can also go to the grid. It can also be used for other processes, for example, hydrogen production for industrial use, green chemistry, black carbon, and so on. And the worms unit for drying the material, for heat supply, it can be used for buildings and villages. The GIZ is a part of the instrument of German Ministry of Economic Cooperation and Development. Because Neumann can be here today, I'll give you just a short overview about the activities of the GIZ. The main task is to build bridges between partners, official, development, and private, so-called PPP projects, private-public partnership. Another target is creating the added value for the public development, also continuing of the use of resources, diversification to the coffee farms, and creation of CO2 sequestration for the climate production.
So yeah, thank you very much, Mr. Kova. Sorry for that. I was just getting a secret message on the password for the Wi-Fi that maybe some of you guys would like to use. Like I told you, we're getting better here every minute. And you will get the Wi-Fi password in the break. So I have something to still hold your attention level. Okay, there are some questions.
Yeah, hello. Thank you for your good presentation. My name is Rainer. Is there an installation out there which is economically viable, which pays off for all stakeholders?
Sorry, I can't hear you.
Okay, so is there a project already implemented and up and running which pays off for all of the stakeholders, for the farmers and for you as a company? Do you have an example, a good example, where it's really economically viable?
We have two plants working right now in a technical size. One is in France and the other one is here in Germany near Buchen im Odenwald. We have practical experience with about 50 different sorts of biomass, and we also have many energy tests. It means we get more energy out than we put in. And for the financial aspect, you can say you'll have an ROI between 1.5 and 3.5 years.
Is that question answered? Okay. More questions here?
It's just an observation about the application for energy that is something that is, there are some project viable.
Bringen Sie ihr ruhig das Ding mal.
And I think that, for example, Nestle in Spain is using the Spain coffee grounds as a source of energy in their own production. Then I think that is possible, the use of the byproducts as in a viable way, economic way, in my opinion.
I think the new thing about a standard biogas is the cracking. So that is, when I heard it in the beginning, I had to listen twice to get the difference. It's a little but relevant difference. And yeah, but I really believe that we are, of course, like with a lot of things in the beginning of technologies, but certainly we are. I think there was one more question, Christoph.
Yes, thank you. Maybe it is too detailed of a question, but I was looking at the parameters of a farm. I think it was in Brazil, maybe a theoretical example. What I didn't catch was the amount of biochar that was produced from all the organic matter that was described.
1 ton of biomass waste is about 300 kilo of biochar, and the other is gas. And 1 ton of biochar is about 3 times more CO2 equivalent.
Can you say that again, please?
Pardon?
Can you repeat, please, the last part? The last sentence that you said.
The 1 ton of biochar is about 300 kilo. No, sorry. 1 ton of biomass waste is about 300 kilo of biochar, and the rest is gas. And 1 ton of biochar is approximately 3 tons of CO2 equivalent.
Thank you so much.
Okay, any more question? You see, this is like going to mathematics. Yeah, there's the microphone is coming to you. You remember in the first class when it said like 3 guys travel, 1 has a fast boat, you know, that's a little bit where we are. Okay. Yeah, but all the tricks. Okay, here's another question.
So thank you for the microphone. One question on the CO2 footprint. Can you tell something about that? How is the process you apply? Can you tell something about the footprint? Because I saw that you need a lot of warming energy to dry the material at first. Maybe it's no problem in areas where there's a lot of sun, but maybe here we have some problems about drying to 80% coming from 32.
We don't need any external energy. We dry the biomass waste if it's less than 85% dry matter with the warmth, with the energy we get out from the process. And at the end of the process, we still have energy which we can use external.
Okay, so about this CO2 footprint, it should be, it reduces the footprint.
I haven't got it.
So about the CO2 footprint.
Yes?
The process is an option to reduce it.
Yes, the CO2 footprint will be reduced very, very much because every ton you bring into the farmland, you get it out from the CO2, how do you say, Kreislauf?
Circle.
Circle.
Okay, thank you.
Okay, so I think this is the perfect moment to cut and let you run into the coffee break, because that gives you the chance for direct talks. And I'm saying thank you very much, Mr. Kova. He will also stay here, I hope, a little bit. And there's also a present for you.